Last time we learned about the electron structure of atoms, how the electrons are arranged in orbitals and shells around the nucleus of the atom. I mentioned that noble gases have full outer shells, as in their outer shell has no room for any more electrons. You may know about the noble gases. There's helium, there's neon, argon. They are very unreactive. That is because a full outer shell makes them stable. It means that they're very happy how they are, they don't want to interact with anybody, thank you very much, they've got full outer shells, they like it. The other elements, however, don't have full outer shells. For example, sodium has an electron structure of 2, 8, 1, meaning that it has one electron in this outer shell. For all of the atoms that are not noble gases, this makes them unstable. It makes them reactive. And what they want out of life is to become stable. They want to mimic the noble gases. So let's take a look at these two examples, sodium and chlorine. Sodium has an electron structure of 2, 8, 1. Chlorine has an electron structure of 2, 8, 7. One is a reactive metal, one is a reactive toxic gas. Now, you may know that they form the compound NaCl, sodium chloride, or common table salt. But in order to do that, they do it in order to become stable. They do it in order to have their outer shell mimic the outer shell of the noble gases. And they do it by forming ions. And the sodium has two choices. It's got one electron in its outer shell. It could gain 7 electrons. It could fill up all of the empty spaces in there by pulling in 7 electrons from the outside. That would take a lot of energy, 7 electrons. Or, if we take a look at its second shell, that's already full. It's got 8 electrons in it. So its other choice is to lose this electron, kick that electron out. In which case, it becomes still sodium, still has the same number of protons, but now it has an electron structure of 2, 8, which is the same as neon, making it really stable. However, it has 1 fewer electrons than it had before. It has the same number of protons. If you remember back to last time, that would make the charges unbalanced. So what we do, put a little box around it and write the charge, which is positive, because it has more protons than electrons. The chlorine has a different problem. It's got 7 electrons in its outer shell. It wants 8. It could kick out all 7 of those electrons, just like sodium did, and have this one be its outer shell, but that would take a lot of energy. Instead, what it does is it gains an electron. So it gets an electron structure of 2, 8, 8. I'm going to do the last electron a different color so you know it's a guessed electron. And it now has a full outer shell, stable, but it's got 1 more electron than protons. So it also has a charge, which is minus. These are called ions. An ion is a particle with a charge. It becomes charged by gaining or losing electrons. Sodium has lost an electron to get a positive charge. Chlorine has gained an electron to get a negative charge. Now, you probably know opposites attract. So the positive and negative charge, when you react sodium and chlorine together, stick the ions together. They balance out. If you have 1 positive charge and 1 negative charge, you get a ratio of 1 to 1. Sometimes, for example, magnesium chloride, you might get 2 chlorines for every magnesium, as long as the overall charge is 0. Because the overall charge is 0, sodium chloride has no charge, even though it's made of charged particles. This is an electrostatic attraction between the positive and the negatively charged particles. That makes them very stable. Sodium chloride is quite unreactive, as an example. And if you react them together, they end up forming giant compounds, giant ionic compounds made of alternating positive and negative ions. We'll look at more complicated ionic structures next time.